Hello friends, in this topic we are going to understand what are the types of lasers in this chapter, and particularly helium neon laser will be understood with principal construction and working. So what are the types of laser we are going to understand over here are helium neon laser. First we will be learning, then in further next sessions we will be learning ND-YAG laser and semiconductor laser also. So the question particularly arises, what is the schematic diagram or explain principal construction and working of HE laser, that is helium neon laser. So here in this diagram what we are observing, the resonant cavity is made up of two mirrors, mirror M1 which is 100% reflecting and semi-transparent mirror M2, and both are concave mirrors, and in between these two mirrors the discharge tube with glass quartz plate windows is there, in which cathode and anode are connected to high voltage but DC type of supply. Then here helium neon gas mixture is settled in this tube, and by using stimulated absorption, spontaneous emission, achieving metastable state, population inversion, and thereby following the stimulated emissions which causes lasing action. And what is the action involved here? Electric field causes electron to move towards right and ions to move towards left, which are positive ions. So left is the cathode and right act as a anode. This is about helium neon laser and its construction. Let's understand it in deep. Helium neon laser device consists of narrow discharge tube filled with He and Ne gases in the ratio of 10:1. The ratio is important, which is 10:1, and under a pressure of 1 mm of mercury. Very less pressure it is. Then two flat glass quartz plates working as window are sealed at the either ends of tube, as we saw this structure in the diagram. Two concave mirrors M1 and M2, as I say, one is 100% reflecting, another is semi-transparent. So this is the construction of HE laser, and what is its working. So the energy level diagram for HE laser is this one, and what happens over here, the atoms in lower energy level E1 are provided with the energy, and they jumps to higher energy states from E1 to E2, E3 and above levels. So HE laser employs 4-level pumping scheme. So types of pumping में हमने देखा था कि 3-level pumping भी होता है, 4-level pumping भी होता है. What is there in 3-level pumping? From energy level E1 to E3, it's a 3-level pumping, and from energy level E1 to E4, it's a 4-level pumping. So helium neon laser uses 4-level pumping scheme. And when the high voltage DC supply of about 1 kilovolt is switched on, the electric field ionizes some of the atoms in the mixture of helium and neon gases. So which type of energy we are using here is electrical energy, which gives the stimulated absorption for atoms lying in lower energy state E1. And due to this electric field, the electrons and ions get accelerated towards the anode and cathode. The helium atoms are more readily excitable than the neon atoms because they are lighter. So helium will be acting as an active medium and neon will be acting as a host medium. As shown in this diagram, the 4-level pumping will make the transition up to E4. From there, spontaneous emission and metastable state will be achieved, and these arrows are showing what? These are showing stimulated emissions from metastable state to lower energy levels. Now, the electrons excite helium atoms through collision and excites it to E2, E3, which are metastable state, and the excited helium atoms cannot return to the ground state by spontaneous emission of photons. Obviously, in stimulated emissions, we have to give external energy to stimulate the emission from metastable state. So as the discharge current increase, more and more helium atom accumulates in the excited state. Why more and more atoms we are accumulating? Because to achieve metastable state and population inversion. So these excited helium atoms can return to ground state by transferring their energy to neon atoms through collision. And if both of them have identical energy states, the E6 and E4 levels of neon atoms nearly coincide in energy with E3 and E2 levels of helium atoms, and which return to ground state after transferring the energy. Now the Ke of helium atoms provide the additional energy for exciting the neon atoms to E6 level, and this is the main pumping mechanism in HENE system. The population of neon atoms increases rapidly, and therefore population inversion takes between E6 and E4 with respect to E6 and E3. Now the neon atoms are the active centers, and the role of helium is to excite the neon atoms and causes the population inversion. Clearly, probability of energy transfer from helium atoms to neon atoms is more, as there are 10 helium atoms to 1 neon atom in the mixture. Now, there are following transitions which you can observe here. From E6 to E5, from energy level E6 to E5, it gives a laser radiation of wavelength 33,912 angstrom, which is in the infrared region, and hence they are not visible. From energy level E6 to E3, it gives the laser radiation of wavelength 6328 angstrom, which is of red color and it is visible. And the transition from E4 to E3, it gives a laser radiation of wavelength 11,523 angstrom, which is again in infrared region, and hence it is not visible. So as per our requirement of application, we can set the transitions. E2 level is a metastable state, therefore neon atoms tend to accumulate at this level once again. However, when they drift towards surrounding discharge tube wall and collide with it, they give up their energy and return to ground state. These atoms are to be brought to ground state quickly, and therefore to increase the probability of atomic comic with the wall, the discharge tube is made narrow. As the discharge is continuous, the laser emission is also continuous. Therefore, HENE laser is called as continuous wave laser. Which laser is called as continuous wave laser? Helium neon laser is called as continuous wave laser. Now the question will be asked like, what are the merits of helium neon laser? So let's understand one by one. Its output is continuous from 0.8 milliwatt to 22.5 milliwatt at 6,328 angstrom. Second merit of this is 3 types of transitions are available for you from E6 to E5, means you can produce infrared light also. So we are having transition from E6 to E5, which gives the radiation of 33,912 Armstrong, and this is in infrared region which are not visible. So low energy transition, or you can say low energy lasing action, is also available here. E6 to E3, which gives the red color light, and the third transition, which is again in infrared region. The third important merit of this laser is it gives a highly monochromatic red color. A single color light you can obtain using helium neon laser. The helium neon laser is highly stable, since the He and Ne gases are found in most pure form. Therefore, helium neon laser operation is accurate and reliable, and it requires less pumping power. As we saw, it is in megawatt. As we saw, it is in milliwatt. So it requires less pumping power. Now we'll be moving towards the demerits of helium neon laser. So the first demerit is that there are 3 available wavelengths of the laser output from helium neon laser. The first is in infrared region, third is in infrared region, and only 6,328 Armstrong is available as a red color emission, or it is in visible region. Therefore, to obtain one particular wavelength, the other 2 wavelengths require to be suppressed, which is achieved by several techniques and devices, which requires proper design, and this causes higher cost of this laser. So you can simply say in helium neon laser the cost is high. Also, helium neon laser requires high voltage, about 1 kilovolt or 1000 volt to 1500 volt DC, and which is costly and needs safety precaution. The third demerit is the concave mirrors used as optical resonator get usually eroded by the gas discharge and need frequent replacements. So the concave mirrors which are used in resonant cavity are frequently needed to be replaced. Now, what are the applications of helium neon laser? Helium neon laser is mostly used in holography. What is holography? We will be learning that in later part of the chapter. It is used in communication equipments, it is used in research activities, it is used in weapons, it is also used in barcode scanning. So आप डीमार्ट वगैरह में देखते हैं, बिग बाज़ार में देखते हैं, यहाँ वहाँ पर जो स्कैनर है उसके अंदर obviously what is it? It is lasing action. It is used in laboratory demonstrations of optics, and it is also used in interferometers where it employed to make precise measurements. So this is all about helium neon laser. Thank you.